Welcome to our unit on solutions. Some of this should be familiar to you. It's not the first time you're hearing of a solution. We've used solutions all year. In general, they are stable, homogeneous mixtures. So for example, if I make a solution of salt water, it is stable. The salt stays dissolved unless I evaporate the water or something like that. And it is homogeneous. You can't see the particles of salt versus water. It's evenly mixed. And by saying that a solution is a mixture, we mean that it is a physical combination. I can obviously separate the solvent and the solute, the water from the salt. Maybe I evaporate the water, but it's a physical combination. Speaking of solvent and solute, the solvent is the substance that is doing the dissolving. It's often a liquid, and of all liquids, it's usually water. It doesn't have to be water, which we'll talk about eventually, but most of the solutions that we make are water-based. Now, if you don't have a solution with water as your solvent, one way of deciding what particle is the solvent is that it's usually the particle present in a greater quantity. So there are some things that might not dissolve in water. There are things that maybe need to dissolve in oils. So if oil is by far your more abundant particle in the solution, then the oil would be considered the solvent. The solute is the material that you're trying to dissolve. It's often a solid, but it doesn't need to be. It could be liquid or gas. And in general, it's just whatever is present in a lesser quantity. Some examples. Different kinds of solutions. I mean, again, if we stick to this definition of it being a stable, homogeneous mixture, you could have gases mixed with gases. So, for example, air could be thought of as a solution. Air is stable. Obviously, there's different gases, but they're mixed together and they stay evenly mixed, making it homogeneous. And air is a mixture. It's a physical combination of gases, and they keep their individual properties. You could have a gas in a liquid like soda water, carbon dioxide in water. Stable, homogeneous, and a mixture, physical combination. Two liquids could mix together, water and alcohol. They're stable, they mix well, they're homogeneous. You can't see the different substances, but yet they can be separated. Often alcohols have a lower boiling point than water. So they might only boil at maybe 70 degrees, whereas water boils at 100 degrees. So I could heat my solution to about 70 degrees, and the first vapors to be formed would be my alcohol. Now, often we think of the solid in liquid, like the salt water. Another goofy example might be something like brass, a solid in solid. I love this like old English spelling of zinc with a K. We call this an alloy. It's a mixture of metals. And so obviously if I think of brass, I don't usually think of it as a solution, but it is stable. It's a mixture of metals. They keep their individual properties, and that's why we mix them together. Now, brass is a mixture of copper and zinc. The zinc makes the copper stronger, but doesn't dull the color. Like 24 karat gold. You would not want gold jewelry that's 100% gold. The gold is really soft. It would scratch, it would bend. It would not make for good jewelry. So it's alloyed with something like copper. That might be harder, sturdier, but yet doesn't dull the color. So down below, they give us a couple examples of solutions, and they want us to identify solvent and solute. And some of this can be debatable, but I mean, if I think about Kool-Aid, the solvent is probably water. And my solute is whatever I'm dissolving the Kool-Aid powder, or maybe it's some kind of a concentrated liquid. I'll say the Kool-Aid powder. Sometimes you have to add sugar. I'll put sugar down. That would all be considered the solute. So a simple solution of a solid and a liquid. Carbonated beverages, carbonated water. The solvent is probably the water. The solute. I mean, there's all kinds of things like in real soda. There's obviously sugar and acids and all that. But if it were like straight up carbonated water, maybe I would say like the carbon dioxide bubbles are my solute. A solution of copper 2 chloride. Okay, so we're going to make solutions. You've used solutions all year, and I mean, secretly you have made them. We may not have thought much about what we were doing at the time. Copper 2 chloride is a solid. It's like a green crystalline solid, ionic solid. When I make a solution of the copper 2 chloride, I go to the electronic balance, and I measure X amount of grams of my green copper 2 chloride crystal, and I dissolve it in a certain amount of water. And my solvent would be the water, and my solute would be the solid copper chloride crystals. Now, sometimes I've seen questions on tests or quizzes, multiple choice questions, that might say A, B, C, D, which of the following is the solute? Okay, well, number one, the answer is not water. Water is the solvent. Another choice might be like copper. Well, no, think about it. Does copper even dissolve in water? No, I mean, that's why it's used in cookware, copper in pipes and all that. Copper doesn't dissolve in water. Another choice might be chlorine. No, not like chlorine gas. Copper chloride is a compound. You would dissolve the entire compound in the water. It's a solid crystalline compound. That entire crystal is your solute. And then gold coins, again, it would be an example of an alloy. It's a mixture of metals. It doesn't seem like my typical idea of a solution, but the gold is much more abundant. So maybe we would say the gold is the solvent, and the solute might be like the copper, used just to strengthen the gold for jewelry, or coins in this case. Okay, so easy vocab. Solvent, solute. Solubility is a term that we've used throughout the year as well. We've talked about solids being soluble or insoluble. It refers to the ability of a substance to dissolve in another substance at a given temperature. Now, often that substance is water. So a few things that affect solubility, the ability to dissolve. Obviously, temperature. Number one, temperature. If you increase the temperature, you increase the solubility. And we should be able to explain why. And we know now that temperature is a measure of average kinetic energy. So if I increase the temperature, I increase the kinetic energy. Increase the temperature, I increase kinetic energy, which is energy of movement. So now those water molecules are moving around faster, and they have the ability to interact more with my solute. That should increase solubility. It would dissolve faster. I could increase the surface area to increase solubility, which we'll do. Later on this year, we're going to test some antacid tablets, see which ones are better at neutralizing stomach acid. The first step in the lab says to grind the antacid tablet with a mortar and pestle. It just makes it dissolve faster, so you can start the lab faster. By increasing the surface area, again, now there's more exposed area for the water or whatever the solvent is to interact with your solute. So we can always increase the temperature, increase the surface area, use a finer grade particle. We can increase particle movement, which would be known as stirring. Again, we're just trying to think of ways that we could get the solvent and the solute to interact more with each other. And finally, there are some substances that just are not soluble in one another. And then we use the term insoluble. So we've used that with precipitates. Precipitates are things that are insoluble in water. So there, this solution stuff, this is not going to be bad. A lot of this we've used all year long.